Okay, this is worksheet number 10 from your book, the back of your book, page 61. Proving arguments valid or invalid. We'll be using truth tables for the purpose of proving an argument valid or invalid. So it's sideways in your book. I'm going to do it on this worksheet. Okay. So first thing we need to do is fill in the top line, right? We know that each operator and each variable gets its own line, and that these slashes represent premises, and the double slash is a conclusion indicator. What else? And we have 3 variables, so we need 8 rows here. So let's just start plugging them in. And then we assign their truth values. So we're starting from left and we go to the right. The first variable we see gets the first half T's, second half F's. Cut that pattern in half for the second variable that comes in this statement. TTFF, TTFF, all the way down. And then the third variable, so Q will get the same thing that Q has. Third variable is L, and that will go TF, TF, because we cut that pattern in half again. So let's fill in all the Q's, first half T's, second half F's, and then fill in this L. It's the same as the other, TF, TF all the way down. Okay, we move left to right, working out tildes and parentheses first. So let's do this one. These just get negated and become their opposites. And now we use this column and this column to determine this column. And we're using our rules, our truth tables for conjunction. So we're looking for TTT. So we have TT, we have T here, TT, T, and then everything else is F. This is the main operator column for this statement, so I'm going to circle it. We'll be using it. Okay, over here we're going to negate all of these L's, so these just become their opposites. So T becomes F, F becomes T, T becomes F, F becomes T, all the way down. And then we work this out using our disjunct rule here, which is F, F, F. We have 2 of them. Everything else is true. This is the main operator column here. I'm going to do a star and circle it. And then we have our conclusion. So remember, with validity, we're looking to prove invalidity. We're looking for a TTF pattern going across. So no, here's our first T, no. TTF, we've got one. That's the only one that we have. But this argument is invalid because it's possible for it to have all true premises and a false conclusion. Sorry about the terrible handwriting. Okay, number 2. So we have to write the values in. Parentheses have to share. Okay, then we write in all of our values. So the first one gets TTTT, FFFF. Second one is N, it gets TT, FF, TT, FF. The third one we see is a Q, and that gets TF, 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 TF. And then let's just transfer all of these values over to the other variables that we see, the duplicates. So M and Q. And then we go left to right, inside parentheses first, doing tildes if we have to. We do. These are just getting negated here. Same thing here, negate these. Okay, so we will use this column to come up with this column. That's the main operator within the parentheses. So we're looking for FFF. We've got F and F. There's one. No, no, no. Yes. No, no, no. T's. Okay, so we'll use this column and this column to come up with the whole statement main operator column. And it is a biconditional. I didn't write it very well, but it's this. So if they're the same, it's true. If they're different, it's false. So we're looking for the same. So TF, no. TT, yes. TT, yes, that's true. Same, same. Different, different, different. So these are all false. Okay, so that is the main operator column for that statement. I'm going to circle that. We go to our second premise here, just negating all of these guys. So F, 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 T, 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 T. And same here. Well, let's circle this column. And then same thing here. Just negating what's right next to it. Circle that column. We're looking for a T, T, F across. So T here, nope. T here, no. T here, no. T, T, F. Okay, so we've got one. And that's it. So same thing. This is invalid. Same reason. Okay, let's go to 3. Write it in. Not M, B, and K. Oops. That's not very good. Ampersand. All right. First variable gets first half T's, second half F's. Second variable, cut the pattern in half. Talking and doing is hard. TTFF, TTFF. And then the third unique variable. So we'll copy the B's, we'll copy those M's, the K. Cut the pattern in half again until you have TF, 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 all the way down. And then we'll just fill in. That's all the variables we have. We'll fill them all in. So B's will all get TTFF. Gosh. Not on my game. Okay. Another B here. And another B here. M's. TTTT. FFFF. Again over here. And K over TF, all the way down. Okay, left to right, tilde. So these all get negated, turn into their opposite. And then we have a conjunction. We're using this column and this column to come up with this column. And we're looking for TTT. Got one there, got one there. That's it. Everything else is F. And then we've got to go inside the parentheses as much as possible here. First, we're looking for TT, so we can put a T. And then everything else is F. And now we use the column that we just came up with and this M here to come up with this statement, or this column, sorry. And we're dealing with the disjunct, so we're looking for FF. No, yes. F. Got a couple there. And then everything else is true. Now we use that column and this column to come up with this column. So, and we're doing a conditional, so we're looking for TF. So TT, TT, FT, FT, TT, TF. This is TFF. That's the only one. Everything else is true. And then we come over, let me circle my main operator columns so far. Okay. And then we do our M here. So we're just negating all of these. That will be our basically main operator column there. Conjunction here, we're looking for TT, T. No, 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 yes. No, no, no. So these are all F. And that's our main operator column for the conclusion. So we're looking for, this is our conclusion separator. We're looking for all T's, premises, and a false conclusion. So we're looking for T, 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 F, no. T, nope. That's it. So this argument is valid because it's impossible for the for all premises to be true with a false conclusion, something like that. It can't be like that. Okay, so that was worksheet 10. I hope it was helpful.